Good morning to all of you. In my previous video lecture, I have discussed about refraction of light, and we have talked that what do we mean by refraction of light, and also we have seen an experiment to trace the path of the light with the help of rectangular glass slab. So now we will talk about the law of refraction of light. In the reflection part, we have talked about the law of reflection of light. Now here we will talk about the law of refraction of light, and there are two laws of refraction of light. First law says that the incident ray, now here not reflected ray, refracted ray and the normal to the interface of two transparent medium at the point of incidence, like this. These two transparent medium interface of these two transparent medium at the point of incidence all lie in the same plane. So first law says that the incident ray, refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. And second, in the reflection we have seen that angle I is equal to angle R, but here what is the second law? Second law is also known as Snell's law. Second law is also known as Snell's law. And according to second law of refraction, the ratio of sine of angle of incidence to sine of angle of refraction is a constant for the light of a given color and for a given pair of media. That is, sine I upon sine R is equal to constant, and we denote this constant somewhere with n and somewhere with mu. So this is second law. So first law is the incident ray, refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. And second law say that the ratio of the sine of angle of incidence to sine of angle of refraction is constant. That is also known as Snell's law. And this constant, that we say this constant as refractive index. So what do we mean by refractive index? So there are two things. One is absolute refractive index and second is relative refractive index. First, we will understand what do we mean by absolute refractive index. Whenever absolute refractive index of a medium is the ratio of speed of light in air or vacuum. In air or vacuum to the speed of light in that medium. Means we are comparing the speed of light of vacuum to the speed of light in medium. That is, refractive index is equal to N is equal to C upon V. What is C? Its value you all know, 3 into 10 to the power 8 meter per second, and V either it is given, or if any two out of 3 will be given to you, and you have to calculate the third one. And the relative refractive index of a medium 2 with respect to medium 1 is the ratio of the speed of light in medium 1 to the speed of light in medium 2. Means if it is given n to 1, so what is that relative refractive index of a medium 2 with respect to medium 1? Relative refractive index of medium 2 with respect to medium 1. Now here in this relative refractive index, there is air or vacuum is not. Both are medium. Suppose one medium is liquid and other is also means we can say that glass, and both refractive index are different from both means we can say that refractive index are different from each other. Then what will be your N21 means the relative refractive index of medium 2 with respect to medium 1. So it will be N21 is equal to V1 by V2. If it is N12, that is V2 by V1. Okay. So there is one principle also known as principle of reversibility. Principle of reversibility. And according to that, what happens? If we multiply N21 into N12, then the output will be how much? 1. Output will be how much? 1. So here there are some numerical which I have solved for you. What is the refractive index of a medium in which the speed of light is 1.5 into 10 to power 8 meter per second. So refractive index is asked of a medium in which the speed of light, means V is given, and how much is V? V is 1.5 into 10 to power 8 meter per second. So we know the formula we have seen just now, n is equal to C upon V. So n is equal to, what is the value of C? It is fixed 3 into 10 to power 8 meter per second upon what is the value of V? It is given 1.5 into 10 to power 8 meter per second. So it will be 2. So the refractive index of the medium will be 2. Second question, the speed of light in an unknown medium is 1.76 into 10 to power 8 meter per second. Calculate the refractive index of the medium. What is asked? Refractive index of that medium is asked. Once again, V is given to you, C you know, then n is equal to C upon V, so it will be 1.7045. Now here it is we have calculated here. Here is the case of relative refractive index, that if refractive index of a water is 4 by 3. Refractive index we denote by sometimes mu also, and sometimes with n also. So refractive index of water is given 4 by 3 and of glass is 3 by 2. And most of the time this question number 3 is asked many times in your board exam. Find the refractive index of glass with respect to water. So refractive index of glass with respect to water, that is Wmg, is equal to refractive index of glass with respect to air divided by refractive index of water with respect to air, that is 3 by 2 by 4 by 3, that is equal to 9 by 8. Now again here it is given, and it is a hot question which is never asked in your board exam, but in competition exam many times this question has been asked, that an object at the bottom of a beaker filled with a liquid up to a height of 10 centimeter. If the refractive index of the liquid with respect to air is 4 by 3, find the apparent depth of the object. Means real depth is given, that an object is at the bottom of beaker filled with a liquid up to a height of 10 centimeter. Height of the water is given as, here real depth is given as 10 centimeter. And refractive index of liquid is also given 4 by 3, so real depth 10 centimeter. The refractive index of water with respect to air is given 4 by 3. So here one more formula, please note down that here refractive index is equal to real depth upon apparent depth. So it is given, a refractive index is given as 4 by 3, and our real depth is it is given as 10. Apparent depth we have to calculate, then it will be 7.5 centimeter. And this is due to what? This is due to the refraction of light, because now the light is moving from air into liquid, and we all know that whenever a light moves from one medium to another medium, it bends. And since the depth is at 10 centimeter, but when we observe, it appears to be at how much centimeter? 7.5 centimeter. So this all about the refractive index. Now in our next video lecture we will discuss about spherical lenses. We have seen about the mirror, that mirror, in mirror we have studied about detailed concave mirror and convex mirror. Now in the lens also we will study about the convex lens and concave lens, and it is very much easy. Okay, and once again I am saying, if you feel any problem, please contact me. Second thing, start making notes up to what I have taught to you, and whenever you feel any problem, you listen my lecture twice and thrice, and if then also the problem is there, then contact me. Thank you.